Today we will start with deadlock. As all of us have already learned about deadlock, I think all of you have must seen the definition of deadlock. We can say that deadlock is an unsafe state, unsafe situation which is not considered desirable in operating system. So before continuing, let me share my presentation and then I will explain what is deadlock. Till now I have explained or I have discussed about deadlock. Can anyone tell me something more about deadlock? Any definitions or anything? Will someone like to tell?
Deadlock are the mainly result of liberal allocation of resources.
And what type of and for getting a system into deadlock, what type of graph is
Circular.
circular? Not circular, it is called cyclic. Of course there is a circle, but it is termed as cyclic graph. Okay, now I am sharing my screen. Okay. So is it audible? Is it visible? My screen is visible to you all?
Yes, ma'am.
Okay. Today we will learn about deadlock. This is the condition of safe state. Safe state, what type of situation we will term as safe state? When the system is not in a deadlock state, then it is called safe state. Okay. Look into it, then I will look into these points, then I will explain it. Okay. Actually, deadlock is a term which is used in concurrent computing system. Concurrent computing means when multi-programming is there. In multi-programming concept, the use of deadlock is done. So in concurrent programming, a deadlock is a state in which each member of a group is waiting for another member, including itself, such as sending a message or more commonly releasing a lock. In operating system, a deadlock occurs when a process or thread enters a waiting state because a requested system resources is held by another waiting process, which in turn is waiting for another resources held by another waiting process. So let us look into the safe state. When a process requests an available resource, system must decide if immediate allocation leaves the system in a safe state. System is in safe state if there exists a sequence P1, P2 up to Pn of all the processes such that for each PI, the resources that PI can still request can be satisfied by currently available resources as well as resources held by all the processes. Pj, it is referred as the subscript, it is written as Pj, where j is less than I. This is the condition of deadlock. Okay. So when Pi terminates, Pi plus 1 can obtain its needed resources and so on. Pi plus 1, it can be referred to as P1, P2, P2, P3, like that. These are some basic facts. If a system is in a safe state, then we can say that there is no deadlock. If the system is in unsafe state, there we can say that there is a possibility of deadlock. And to avoid avoiding the deadlock is also known as deadlock avoidance. Ensure that a system will never enter an unsafe state. That is avoidance. So here the condition, there are three conditions. One, when the system is in safe state, that is there is no deadlock. Second, when the system is in unsafe state, it means there is a possibility of deadlock. And third one is deadlock avoidance, taking precautions, taking measures so that the deadlock situation is avoided. Okay. Now, this is a diagrammatic representation. The system is in unsafe state when a deadlock occurs, and the system can be termed, or it is in safe state if there is no deadlock. All of you remember this, that in Windows programming, resource sharing is a main feature of multi-programming. So for multi-programming, it is needed to share the resources. Resource allocation or sharing of resource should be done in such a manner that deadlock situation don't arises. The resource allocation graph scheme. Resource allocation graph scheme is a type of method where the resources are allocated intelligently to processes so that deadlock don't occur. Claim edge and request edge. There are two types of edges. Claim edge Pi to Rj indicates that process Pj may request resource Rj. That means process Pj may request resource Rj during the tenure of its execution. Then claim edge. Claim edge converts to request edge when a process requests a resource. Then we can say when requested edge, when claim edge converts to request edge, when a process requests a resource. That means the process is not capable of using the resource and he is trying to request, or he is generating a request. Request edge converted to an assignment edge when the resource is allocated to the process. When a resource is released by a process, assignment edge reconverts to a claim edge. So as soon as a resource is released, the assignment edge is converted to claim edge. So up to now we have learned resource edge, claim edge, assignment edge. Resources must be claimed a priori in this system. That means in this type of system, resources are claimed a priori. Okay. Again, this I have explained earlier also. This is the diagrammatic representation, unsafe state in resource allocation graph. Here there are two processes and two resources. The example is explained by taking minimal number of process and minimal number of resources. How many processes are there? Only two processes are there. And how many resources are there? Only two resources are there. Okay. So process P2 to R2, that means process P2 is claiming R1 and process P2 is assigned R2. Similarly, resource R1 is assigned to process P1 and process P1 is claiming for resource R2. So there is a formation of cycle. As soon as formation of cycle occurs, the situation of deadlock arises. Is it clear? I think it is clear. Now again, resource allocation graph algorithm. Suppose that process PI requests a resource RG. The request can be granted only if converting the request edge to an assignment edge does not result in the formation of cycle in the resource allocation graph. What does it mean? That whenever a resource is allocated to a process, it will be allocated through resource allocation graph algorithm. For resource allocation graph algorithm, the request can be generated if converting the request edge to assignment edge doesn't result in information of cycle. If we look into the diagram, it means this dotted edge from P1 to R2, this type of claim, this type of request will not be granted, as it can lead to formation of cycle which will lead to deadlock. Deadlock is not a desirable thing. No one wants to stay stuck in a situation. Like, if you can relate it with real life example also, when you are going through a bus, if there is a jam, there is a two-way traffic, there is a jam, then the bus cannot move out, cannot move front or backward. So similar is the situation of backlog. Deadlock. Now, for deadlock avoidance, removal, protection, a famous algorithm is there. That famous algorithm is known as Banker's algorithm. Banker's algorithm is one of the famous form of algorithm. Have any one of you heard about Banker's algorithm earlier?
No, ma'am.
No, ma'am.
No, ma'am.
Okay.
No.
Yes, since this is the first time you are studying operating system, so you might not have heard. These are several features, characteristics in Banker's algorithm. there are multiple instances. Since banker's algorithm is used for several processes, so there must be multiple instances. Each process must a priori claim maximum use. Can anyone tell me the meaning of this sentence? I am again repeating. Each process must a priori claim maximum use. What does it mean? A priori means beforehand. That means before something occurs, we get the idea. So each and every process will declare at the beginning what is the maximum use of the process. Each process will declare it at the beginning. When a process requests to a resource, it may have to wait. When a process gets all its resources, it must return them in a finite amount of time. These are the features or the requisites of banker's algorithm. We can say that banker's algorithm is a resource application and deadlock avoidance algorithm that tests for safety by simulating them. Banker's algorithm is named so because it is used in banking system to check whether loan can be sanctioned to a person or not. Suppose there are n number of account holders. Listen carefully. Suppose there are n number of account holders in a bank and the total sum of their money is S. If a person applies for a loan, then the bank first subtracts the loan amount from the total money that bank has, and if the remaining amount is greater than S, then only the loan is sanctioned. It is done because if all the account holders comes to withdraw their money, then the bank can easily do it. Okay. So let
मैम
us.
एक बार बताइए ये वाला.
Should I explain this algorithm once?
Yes, ma'am.
Okay. Others have understood, or I need to explain? If I need to explain it once, then don't feel shy. Good that someone told that one explanation is needed. One time I need to explain. But at least try attentively, and once the class is over, try to look into some books or somewhere so that you can understand what is banker's algorithm and how does it work. There are several examples that you will found based on this algorithm. Again, I am repeating. First of all, why the banker's algorithm name? Because it is used in banking system to check whether the loan can be sanctioned to a person or not. Just like similarly, you have seen that whether the resource is allocated to a process or not, that is seen. So the name comes from there. If a person applies for a loan, then the bank first subtracts the loan amount from the total money the bank has. Suppose the bank is having, I don't know how many of you know that bank, that every bank has certain amount of cash per day. It comes to them via a sealed car or something like that. They have different automobile for carrying. All of you must have seen when they
Yes,
replenish
ma'am.
money in ATM. Yes. So
Yes, ma'am.
every day the bank keeps cash amount. Suppose a customer came and he asked for a loan amount, an instant loan amount. These days private banks are given instant loan also. So he asked that I want 5 lakh rupees as loan or 10 lakh rupees as loan. But what does the bank does? Bank first look that there is a shortage of money, or there is so much money is not available with bank officials, so they may deny that request. What is in, suppose there are n number of account holder in a bank and total sum of their money is S. Okay. If a person applies for a loan, the bank first subtracts the loan amount from the total money the bank has, and if the remaining amount is greater than S, then only the loan is sanctioned. It is done because if all the account holder comes to withdraw their money, then the bank can easily do it. When the bank started at 10 p.m., a customer came and he takes loan of 5 lakh. The bank is able to process it. After some time, another customer came, or maybe during official hours, several customers can come and ask for loan. So the banking officials need to check the balance that is available with them so as to satisfy the request of all the customers who are asking for loan. Bank needs to take care of all its customers. Suppose you are a customer, you went to SBI and you asked for loan. They said, no, we will not give you, just go back. Then what you will think? Okay, I will stop the account and I will open another account in another bank which will gives me good facility. So we will stop that. So the customer stops the account, which is a loss to bank. So by banker's algorithm, the name is that because it is based on that principle. The allocation is done based on certain logic. Now, this is more about the implementation part of banker's algorithm. Let n number of process, m number of resource type available, vector of length m, if available, j is equal to k. These are general syntax. Once you start executing it in through your programs, you will find. One is available, another is maximum. Maximum is the process PI may request at most k instances. That means there is a restriction of resources for each process. Each process cannot just request a random number of resources. There is a restriction that say it cannot request more than 5 resources at the same time or more than 3 resources at the same time. Now allocation, all these are n to m cross matrix. Allocation, if allocation Aij, why Aij? Since all these are two-dimensional matrix. So if allocation Ij is equal to K, then Pi is currently allocated K instance of resources. What does it means? Look, the available K, there are K instances of resource type available. That means K instance is available. Suppose there are only 5 instances that are present for a process, and the allocation is done based on the number of instances. If the process wants to, or if the process requests 6 instances of same type, then it will not be accommodated. Need. Need is n cross m matrix. If need Ij is equal to K, then Pi may need K more instances of Ri to complete its task. So this is all about different data structures that will be used for Banker's algorithm. I will request everyone to study properly, download something, buy books, you will get easily. Okay, now let us move to need matrix. It is calculated as max minus allocation. This is example of Banker's algorithm. Look properly. 5 processes are there. P0 through P4. 3 resource types. What are 3 resource types? A, B, and C. These are 3 resource types. A, 10 instances, B, 5 instances, and C, 7 instances. At the starting, when P0 came, then A, B, C, the value was 7, 5, and 3 for instance A, for B, for 3. And P0 was allocated 0, 1, 0. So this is the allocation and maximum available chart. Now what is the available matrix at the end is shown after allocation. The content of the need matrix is defined as max minus allocation. What you will do, I will give you the video lecture link. All of you will study that example and try to solve it in piece of paper. Then you will be able to understand how this problem is solved. The system is in safe state since sequence of process P1, P3, P4, P2, P0 satisfies safety criteria. If the order of processes are changed in scheduling, then that is not acceptable. So order of processes is also important to say if it is helpful or not. Check the request is less than equal to available. Here there is request matrix and there is available matrix. Again P0, P1, P2, P3 with 3 resources A, B, C. P0 needs 7, 4 and 3 instances of A, B and C to complete. However, only 2, 3 and 0 resources are allocated. So allocation cannot be done in such case. It will lead to deadlock. So executing safety algorithm shows the sequence P1, P3, P4, P0, P2 satisfies safety requirement. Now the question arises. These are several types of questions which arise. Can request for 330 for process P4 be granted? Can request for 020 by P0 be granted? These are several valid questions that need to be answered, taking care that the allocation does not leave the system in deadlock. So the allocation can be done in such a manner that the system cannot be in deadlock state. Deadlock detection allows system to enter deadlock state. Detection algorithm, removal algorithm or removal scheme. Maintain wait for graph. Wait for graph is maintained. Wait, what is wait for graph? Ti to Pj if Pj is waiting for if Pj. That means to check if there is a cycle formation that is occurring. It means it keeps track of the resources for safe allocation. An algorithm to detect a cycle in a graph requires an order of n square operations where n is the number of vertices in the graph. This is the resource allocation graph or wait for graph. Look properly how the resource allocation graph is there. Just observe that there is no formation of cycle. Is there any formation of cycle? No. Formation of cycle is not there. As a result, the deadlock situation is not there. Several instances of resource type is available in the system, and we will keep 3 type of attributes. Available, a vector of length m indicates the number of available resource. Allocation n cross m defines the number of resource of each type currently allocated to each process. Request, a n cross m matrix indicates the current request of each process. If request Rij is equal to k, then process Pi is requesting k more instances to a resource type Rj. Okay, so available, allocation and request. These are 3 type of resources. Now, if deadlock occurs, then these are different strategies for recover from deadlock. Process termination. Process termination, abort all deadlock processes. Abort one process at a time until deadlock is eliminated. That means it is not necessary to terminate all the processes. Only the process that is creating deadlock, remove it one by one. In which order should we choose to abort? The abortion of the process is started in which manner? Priority of the process, how long process is computed, and how longer it needs to completion, resources the process had used, resources process need to complete, how many resources will be needed to be terminated, is the process interactive or batch. So these are different strategies of recovering from deadlocks. Resource preemption. What is preemption? You have learned preemptive processes and non-preemptive processes. Preemptive processes are those which can be stopped. Selecting a victim, minimize cost. It means only the process that is creating the deadlock, that is selected and the cost is minimized. Rollback, return to some safe state, restarts process for that state. Starvation, same process may always be picked as victim, include number of rollback in cost factor. Go through this. I know I am explaining all these things hurriedly. If there is any confusion, I will clarify. You can get in touch with me one by one, or if you want, I will explain it in class, in next class also. That's all for today. Is there any confusion? Then there is no time left. So I'm finishing the meeting.